When you calculate a magnitude and suddenly you get a negative value, do you understand what it means? You should actually understand what it means, and you should illustrate that you understand what it means. Bismillah, Assalamualaikum. So in this video we will focus on certain meaning that we have to understand when we get a negative value after calculating a certain magnitude, right? So in a vector it is quite clear, right? So when we have positive I, negative I, positive j, negative j, for example, it is understood what it means, the direction, right? But when we calculate a magnitude, suddenly we have a negative. What does that mean really? Because you cannot say that we have a negative 5 meter. What does that mean? Negative 20 Newton. What does that even mean? Because unlike temperature, where we have 0 degrees Celsius, if we are using Celsius, right? 0 degree is the freezing point for water. And anything above that is above that, and anything below that is below that freezing point. So if you have negative 5 degrees Celsius, we know what it means. It is understood. But when we say negative 5 meter, negative 5 Newton, what does that even mean? Because there's no such things, right? Distance is from 0 until a certain value. That's the distance. And we are talking about magnitude here, right? So when you get a negative value, when you calculate something and then you get a negative value, you should specify what does this mean to illustrate that you understand. It doesn't mean a negative value, or the value itself is not negative, but that negative means something. What is it? You have to illustrate, right? So we are focusing for this video for chapter 2. So 2 examples where this negative can happen, and hopefully it will be of help to you if you are confused about this. The first one is a straightforward one. It's basically when you do summation of a component of forces, right? For example, summation of fx and summation of fy. So if you do summation of fx taken to the right as positive, this is when you want to calculate for a resultant force. For example, if you have multiple forces and you want to find what is the resultant, so normally we break down into the x component and y component. We are talking about 2D now, and we add up all the component and then we get the resultant component. Hence we can get the resultant, right? So when we do this and we assume, or we take positive to the right, so anything that is to the right, for example f1, so we just plus f1 basically, right? Or we have f2 here to the left, and then we have theta, so minus f2 cos theta, and so on. So there's 2 possibilities here because it depends on all the forces here. So one possibility is you get a positive something, right? So it's positive frx. Another possibility is if you get negative frx, right? So what does this mean? This simply means that if you get positive, meaning the resultant is in accordance to this direction. If you get negative, you have to imply, you have to specify that it means that it is actually to the left, right? Hence the component is to the left. So if FORY upwards, then resultant will be there, for example. So this one is quite straightforward, I think, because this already gives you which direction is positive. So anything negative is just meaning that it is in the opposite direction. Now the second topic where we can find where we get a negative magnitude after calculation is when you calculate the projected component of a force. So let's say we have this axis here, right? Okay, my marker is already out, right? So and we have a force in a certain direction here, and we need to find what is this F, the component of this F projected onto this axis. So basically this is F, let's say in the axis of parallel to axis of A, right? Something like that. Right, this is the component. So there's 2 ways that we have learned to calculate. One is if you use the theta, so simply F this parallel A is simply F cos theta, right? But of course, if you use vector, you can also calculate by using f vector dot unit vector of A, right? So if you're doing any of this, is there possibility of having a negative answer? And in fact, it is possible. So if this happen, what does it mean, right? So you have to understand what it means if you get a negative value, so that at the end you cannot just simply leave it there as if, oh, the projected component is negative 20 Newton. What do you mean? Because the magnitude should have a magnitude, but that negative, the force is not having any negative, right? So what does that mean? Okay, so if you can look here, right, as long as this theta is smaller than 90, obviously this f is in this direction, right? So f cos 30 or something, you always will get positive value. But if suddenly this theta goes beyond 90 degrees, it's 100 degrees, etc., if you calculate f cos 100 something, for example, you will get a negative value, right? So it means it is in the opposite direction, right? Obviously, if its theta is like that, f is actually here, right? F here, and this one is in this case 100 degrees, for example. So what is, if you are calculating what is, you imagine this is f parallel to A, this is axis, obviously the answer will be something negative, because no, it's not actually there. The projected component is here, right? So that's why if you assume to the right, you'll get a negative value. Oh, okay, it's actually to the left. So based on this understanding, normally we will not assume there, right? Obviously, when we have axis here and force here, this will be the projected component, right? But in 2D, this is easy to see, but in 3D, right? In 3D, if you have a 3D space, and then you have an axis, so for example, if you have a force somewhere, and then it says what is the projected component of that force along this axis. Now, when you use this one, you have to realize when you use unit vector of an axis, there's two possibilities of that, right? So one is, if you use from this point to this point, let's say this is A, B. If you use RAB divided by RAB, meaning the vector divided by magnitude, you actually get UAB, correct? That defines the unit vector from A to B. But if you use RBA, vector divided by RBA, you actually get unit vector BA. It still describes the same line, the same axis, but in the opposite direction. So when you want to use when you apply this one, without realizing it, you actually have put already the assumption which direction the projected component is. If you use AB, you already actually assume the projected component is in the direction of AB, right? So when you get positive, then correct. When you get negative, oh no, actually it's the other way around. It's actually BA. If you use unit vector of BA, you are assuming it's in direction from B to A. So if you get positive, then okay, correct, it's from B to A. When it's negative, it's actually A to B, right? So that is where, for example, if you get negative something here, you should actually be able to tell what this means based on the assumption. I know most of us do not realize that we actually assume already when we use unit vector, because unit vector of any axis can, just like even if you have force at the origin, right? And I say what is the projected component of this force along, for example, the x, y, z, right? What is the projected component of this force along y axis, right? So I can say, okay, to use F parallel to y axis, I can use vector f dot by unit vector of y, which is j, right? But by doing so, I already embedded the assumption that the component, the projector component, will be in positive j in this direction, right? Because y-axis is also meaning that you can also dot negative j, right? If you want. So without realizing it, you already assume which direction is the component, right? So in this case, if you use dot j and this f is on that to that side, to that direction, you will get a negative value there. For example, you'll get a negative value here, right? Negative something. So you have to be able to tell, oh, this negative means actually it is in negative j direction or something, just to indicate that you understand what it means and you do not just know how to blindly calculate and do not know what is anything mean, right? So that's it for this video. It's just to illustrate that you should be able to tell whenever you get a negative value, because there's no such thing as negative force or negative distance in this 3D world, right? It's distance is from 0 to something, force is from no force to some force. There's no like, how do you have negative force, right? It doesn't exist. But it means something else in the calculation. It means, oh, we assume that direction is actually in that direction, for example, right? So you have to be able to tell whenever you have a negative value, you know, in your answer. Hopefully this helped. With this, thank you and see you next time.